Hello students. So today we are going to start a new chapter, arithmetic and geometric progression. This is these are the topic that you are going to learn in class 10 only. So arithmetic and geometric progression, what is arithmetic? We are going to cover what is sequence and progression. So the difference between sequence and progression that we will cover in this particular video. Arithmetic progression and common difference. What is arithmetic progression and what is common difference? What is geometric progression and what is common ratio? So common ratio is related to geometric progression, common difference is related to arithmetic progression. And then we'll do few of the examples where you will understand the difference between sequence progression and then arithmetic progression as well as geometric progression. Arithmetic progression, in the short form we say AP, A for arithmetic, P for progression, and geometric progression, the short form is GP. So this is the first class on arithmetic and geometric progression. There will be few classes to cover up the entire topic of arithmetic and geometric progression, right? So okay, so first understand what is sequence and then what is term, what is progression. Then we'll come to arithmetic and geometric progression. I suggest you to understand each of the class of arithmetic and geometric progression. If you understand each of the videos, then the entire chapter will be, fundamental idea will be clear to you, and I'm sure all the related problems, all the problems related to AP and GP, you will be able to solve. So please go through all the videos in my channel on arithmetic and geometric progression. Okay, so what is sequence? Sequence is nothing but a group of numbers, those follow a certain pattern. Sequence is a group of numbers, those follow a certain pattern. This is the highlighted term. Okay, now let's say there is a pattern that you have already done in 5, 6, 7, 8, but you didn't know these names, right? Let's say there are certain numbers, those are given in this order: 2, 5, 8, 11, and so on, right? So if you look into this group of numbers, they are in certain order: 2, 5, 8, 11. What is the difference between 5 and 2? It is 3. So second term and first term difference is 3. Third term and difference between third term 8 and second term 5, it is 3. Difference between fourth term and the third term, the difference is 3. So all the cases we can see the number is the group of numbers, those are increasing gradually, and the difference between each of the consecutive term, consecutive means immediately after that term, the difference is 3. So this is maintaining a certain pattern. So this is an example of sequence. Now let's say number in a sequence, let's say 4, 8, 16, 32. All these numbers in this particular sequence is called term or element. Here 2, 5, 8, 11. These are the numbers in this sequence or in this group of numbers. So these are called term or element. So in this particular group of numbers, if you see the second term, the ratio between second and first term is 2, 8 by 4, 2. Ratio between third term and second term, 16 by 8, 2. Ratio between fourth term and third term, 32 by 16, that is 2. So here the difference is not common, but the ratio between the number and its predecessor is 2. So 8 by 4, 2, 16 by 8, 2, 32 by 16, 2. So this is also maintaining an uniform pattern. This is also actually certain pattern it is maintaining, not necessarily uniform pattern, certain pattern you can say, or uniform pattern, whatever it is. So then it is a sequence, right? But not necessarily in sequence every consecutive term. This is also a sequence where we can see every consecutive term has the relationship, maintaining a relationship with its predecessor. But not necessarily always this is true for a sequence. I am giving you this example where you can see the relation it is there between the element of that sequence with its predecessor. But I am giving you now another example where you will see there is no relation directly between any term with its predecessor, but in a different way there is a pattern. Let's say there is a sequence where there is no relationship between any element with its predecessor or successor directly. Let's say this is a sequence 3, 5, 8, 13, 21, 34 and so on. Here neither any of the term in this sequence is directly related to or uniform maintaining any certain pattern straight away with its predecessor or successor. But there is a pattern. How the pattern is there? First term plus second term is the third term. So 3 plus 5 equals to 8. Second and third term summation is the fourth term. So 5 plus 8 is 13. Then 8 plus 13, third and fourth, it is the fifth term, 21, 13 plus 8. Then 13 plus 21, it is 34. So it is also maintaining a pattern. So this is also a sequence, right? So wherever a group of numbers those follow a certain pattern, that is called sequence. And each of the number in a sequence is called term or element. That is the second one. Term. Each number in a sequence is called term or element. Got it? Now we are coming to progression. What is progression? Progression, the first two examples what I have given for sequence, when each term or element, this is the highlighted one, each term or element in a sequence is related to predecessor or successor, to its predecessor and successor by a uniform law. So there, that is called progression. That means if you have a sequence like 2, 4, 6, 2, 4, 6, 8, 10, this is a progression. This is a sequence which is having each element related to its predecessor and successor with a uniform law, but the difference between two consecutive elements is 2. 4 minus 2, it is 2. 4 minus 2, it is 2. 6 minus 4, it is 2. 8 minus 6, the difference is 2. 10 minus 8, the difference is 2. So this is a progression and sequence, but progression. Another example, here it is 3, 6, 12, 24, 48 and so on. So here also each element is directly following an uniform law to directly related to its predecessor or successor with an uniform law. What is the law? The difference is not same, but the ratio between two consecutive terms is same. 6 by 3, it is 2. 12 by 6, it is 2. 24 by 12, it is 2. 48 by 24, it is 2. This is also a progression where the ratio between two consecutive terms is equal. So what we learned, so any progression is a sequence, right? But all sequence are not progression. Any progression is sequence, but not necessarily every sequence is a progression. So every progression is sequence, but every sequence may not be a progression. It may be a progression, it may not be a progression. If in a sequence two consecutive terms or elements are related by a uniform law, then it is a progression. But if every consecutive term or each element is not related to its predecessor or successor with a uniform law, then it is not a progression, but it may be a sequence if it is following some other pattern, right? Now we'll come to arithmetic progression and geometric progression, right? So now we'll understand what is the arithmetic progression and common difference, and then what is geometric progression and common difference, right? Sorry, geometric progression and common ratio, and therefore you will understand what is the difference between arithmetic progression and geometric progression, right? So now what is arithmetic progression or AP? Arithmetic progression is what we understood already in about progression. When in a sequence any term or element is related to its predecessor or successor by a uniform law, that is called progression. So for arithmetic progression, that uniform law is the difference between two consecutive terms is always equal. If in a sequence the difference between two consecutive terms, or in a progression the element or term is related to its predecessor or successor by a uniform law where the difference between each consecutive term is same or equal, that is called arithmetic progression. So let's say there is a sequence where 4, 7, 10, 13 and so on. So 4 is the first term of this progression or sequence, because it is both sequence as well as progression. It is maintaining a pattern and it is uniform pattern between two consecutive terms, because the difference between second and first term is 3, 7 minus 4, 3. The difference between third and second term is 10 minus 7, 3, and so on. Between 13 and 10 it is also 3. So this is called arithmetic progression where the common difference is equal. So, and the difference which is common between every two consecutive terms, that is called common difference, or in short form it is CD. Right? But in geometric progression, the relation between two consecutive terms in a sequence or progression is not the equal difference between two consecutive terms, but the ratio between two consecutive terms are equal. Let's say it is 5, 10, 20, 40, 80 and so on. So what is the ratio between second and first term? It is 10 by 5, 2. What is the ratio between third and second term? It is 20 by 10, 2. What is the ratio between fourth and its predecessor third term? That is 40 by 20, that is 2. Right? And if you consider with respect to successor, then 5 by 10 it is half. 10 by 20 it is half, 20 by 40 it is half. But we'll say common ratio when what is the ratio between any term with its predecessor, that is called common ratio. So here this is called when the common ratio between two consecutive terms is equal, that is the ratio between two consecutive terms is equal, then that pattern or that progression or that sequence is called geometric progression or GP. So here the common ratio is 10 by 5 equals to 20 by 10 equals to 40 by 20 equals to 80 by 40 equals to 2. So everywhere the ratio between two consecutive terms is 2, that is called common ratio or CR. And for this arithmetic progression, everywhere the difference, that is 7 minus 4 equals to 10 minus 7 equals to 13 minus 10 and so on equals to 3. So this is called common difference or CD. So in arithmetic progression, the equal difference between two consecutive terms, that is called common difference, and in geometric progression, the ratio between two consecutive terms is called common ratio. Okay. Now I am giving you few examples wherefrom you can clearly understand which sequence is which is a sequence cum progression, which is a sequence progression, AP arithmetic progression, which is sequence progression, and geometric progression, which is sequence and progression but neither arithmetic progression or geometric progression, and finally which is not at all a sequence. Okay, just try to understand this table, right? Let me just understand what I am going to explain you, and then probably AP GP sequence, there will be no doubt about the difference, and then I will take different class definitely on explicitly for arithmetic progression and geometric progression. Okay, now there are group of numbers like this 3, 5, 7, 9. So we can see there is a specific pattern. There is a specific pattern in this particular group of numbers, right? 5 minus 3 2, 7 minus 5 2, 9 minus 7 2. That means it is a sequence. Progression, whether it's a progression, then I will see 4, 8, 16, 32. 8 by 4 2, 16 by 8 2, 32 by 16 2. Everywhere between two consecutive terms it is ratio is 2. So it is also continuing a certain pattern, right? This is sequence. 4, 8, 32, 92, right? Here is also this line I will explain separately, right? Then 2, 3, 5, 8, 13, 21. So here you can see 2 plus 3, first and second term, addition, summation is cumulative is third term. 2 plus 3, 5. Second and third term cumulative is the fourth term, 3 plus 5, 8. Third and fourth term cumulative is the fifth term, 5 plus 8, 13. And 8 plus 13 is 21. So this is also continuing a certain pattern, right? So this is also a sequence. 5, 6, 9, 11 and so on. We don't see any specific pattern in this particular group of numbers. So this is not at all a sequence, right? Now for this one, first one, whether for each of the row I will just explain you whether it's sequence or progression, AP and GP, yes or no, right? So 3, 5, 7, 9. Two consecutive terms. What did we say in progression? Progression, every element in a sequence will be related to its predecessor or successor with a uniform law. We don't know what is the law, but with a uniform law. Here also you can see this is a uniform law. 5 minus 3 2, 7 minus 5 2, 9 minus 7 2. So the difference is equal. This is the uniform law. This is what, that is why it is progression. And what kind of progression it is? The difference is equal. That is the uniform law between two consecutive terms. That is why it is AP. It is not GP. And what is the common difference in this particular AP? CD equals to 2. Right? Now 4, 8, 16, 32. It's a progression? Yes. Between two consecutive terms you have an uniform law. It's maintaining a uniform law. 8 by 4 2, 16 by 8 2, 32 by 16 2. So that means the ratio between two consecutive terms in this particular sequence is equal. That is why it is progression. Yes. And what kind of progression it is? It is not AP. It is GP. Geometric progression. And therefore in GP what is the common ratio? Common ratio is equals to 2. Now in 2, 3, 5, 8, 13, 21, in this particular group of numbers we can see it is a sequence, but we don't see any uniform or any relationship of any term with its predecessor or successor, and this is no progression between, there is no uniform relationship between two consecutive terms or between of any element. That element doesn't have any relationship to its predecessor and successor by a uniform law. So therefore it's not a progression. That is why it is sequence but not progression. Therefore no AP, no GP. 5, 6, 9, 11. There is no pattern at all in this group of numbers. So neither it is sequence, nor progression, nor AP, nor GP. Now, so I hope from this table it is very much clear to you the difference between these four: sequence, progression, AP and GP. And you remember what I told you already, any sequence may not be a progression, but any progression is always a sequence, right? So I hope you understood clearly about the ideas. Then in the second class I will come and discuss about arithmetic progression in detail, right? So if you like this video, click on like button, and if you would like to have this kind of video again and again, please subscribe my channel. You will have your fundamental idea against each chapter very much clear. Okay, thank you very much.